Next, we're going to look at the area of the region between two curves that happen to intersect. So in this one, I've got f of x equals 3 minus x squared and f of x equals 2x. So I'm going to first start out by sketching a graph of these two equations and find the region that's actually between them. So if I graph the two functions, this is the graph that I get, and we can see that the region that is enclosed by the two curves is this region right here. So this is what we're looking at the area of. Now sometimes you can sort of guess what the bounds are by looking at the graph, but I do recommend that you actually calculate the intersection points. So these are going to be the places, the x values of the intersection points. We don't really care about the y right now, but actually go ahead and calculate those out using algebra, because sometimes the graph can be a little bit deceiving and it may look like an integer, but it's not. So what I do to find those is I've got y equals 3 minus x squared and y equals 2x. So I'm going to set the two y's equal to each other and solve. So this one happens to be 0 equals x squared plus 2x minus 3. It does factor to be x plus 3 times x minus 1. So if I set each of those equal to 0 and solve, I would get x equals negative 3 and 1. So those are my two boundary points. And if you couldn't factor, you might try using the quadratic formula or something like that. So the area would be the integral from, we're going to go from the lower bound to the upper bound, so from negative 3 to 1. And we're going to start with the function that is higher on the graph. So that in this case is going to be 3 minus x squared. And we're going to subtract the lower function, which is 2x, and integrate that. So I get, if I integrate this, I get 3x minus x cubed over 3 minus 2x squared over 2, all from negative 3 to 1. And I can simplify just a little bit and get 3x minus x cubed over 3 minus x squared from negative 3 to 1. So I will have 3 times negative 3 minus negative 3 cubed over 3 minus negative 3 squared. And we're going to subtract. Oh, sorry, actually went backwards with that. Be very careful about your order. We want to plug in the 1 first. I've been trying to do that this whole problem. 1 is greater than negative 3, guys. So I'm just plugging in the negative 3 now. And I'm going to evaluate all this arithmetic and simplify. So I get 3 minus 1/3 minus 1. And I'm going to have minus negative 9 plus 9 minus 9. So these two go away automatically. And when I add all of these together, I get 32 over 3. And that's going to be units squared. Next, we're going to look at the problem that says to find the area of the region bounded by the graphs of f of x equals x squared and f of x equals 3 minus x squared. So you'll notice that we've graphed 3 minus x squared, we've graphed f of x equals x squared, and we found where we found the region in between. Now I'm not the best shading grapher, so I am going to I don't see anything that looks like an integer in the intersection points here. So I am going to calculate them by setting the two equations equal to each other. So x squared will be 3 minus x squared. And if I add x squared to both sides, I get 2x squared equals 3. Dividing by 2, I get x squared equals 3 halves. And if I take the square root of both sides, I get plus or minus the square root of 3 halves, or plus or minus the square root of 3 over the square root of 2. And when I rationalize, I get plus or minus square root of 6 over 2. So definitely not an integer, so we would not have been able to recognize that from the graph. So the area then is going to be the integral from the negative square root of 3, or sorry, negative square root of 6 over 2 to the positive square root of 6 over 2. And I want to make sure that I have the uppermost function first, and that appears to be the 3 minus x squared. And I'm going to subtract the x squared function from that and integrate. So when I do that, I can simplify a little bit. So I'll have the integral from negative square root of 6 over 2 to square root of 6 over 2 of 3 minus 2x squared, because I've got x squared twice with a negative. And that will give me 3x minus 2/3 x cubed when I integrate. And from here, we just need to deal with the arithmetic. Okay, so dealing with all of this, we're going to have 3 square root of 6 over 2 minus 2/3. When you cube a square root, you multiply 6 by itself, or square root of 6 by itself, which gives you a 6. And then you have one more square root of 6. And then when we cube the 2, we get an 8. We're going to distribute our negative here. So we will have minus 3 times negative square root of 6 gives me plus 3 square root of 6 over 2. And then the same kind of deal here. We're going to have, let's see, a positive here, and then this one will be cubed. So this will end up being negative 2/3 and then times square root of 6 square root of 6 over 8. So some things will cancel. You'll have, let's see, this will cancel and leave a 4. This will cancel and leave a 2, which cancels with one of these. And we have the same thing happen here. So we're basically just left with a 2 in the denominator. So I end up with 3 square root of 6 over 2 plus 3 square root of 6 over 2 just gives me 3 square root of 6. And then we end up with minus square root of 6 over 2 minus square root of 6 over 2, which is minus square root of 6. And I'm left with 2 square root of 6 units squared. This example says find the area of the region bounded by the graphs of f of x equals 3x cubed plus x squared minus 5x and f of x equals negative x. So I'm going to graph those. And when I graph the two functions, this is the graph that I get. Now we're looking at the area that's bounded by those two graphs. And when I look at this one, I actually see two separate sections here. I see this portion right here. And I also see this one right here, where we're bounded. So we're going to have three separate bounds. If we set these two equations equal to each other, you can see they intersect in 3 places. So 3x cubed plus x squared minus 5x equals negative x. And if I add x to both sides, I get 3x cubed plus x squared minus 4x equals 0. I can factor out an x, which will give me 3x squared plus x minus 4. And then I can factor the trinomial here and have x minus 1 times 3x plus 4. And that will give me 0. So I get bounds of 0, 1, and negative 4/3. That's the fraction that we see over there. Now when we set up our area, we're going to need two separate integrals because we're going to need one for each of the individual sections. So the first one is going to go from negative 4/3 to 0. And let's just check. It looks like the function, the cubic function, is definitely the higher function on this section A here. So we'll call this A. So we're going to have 3x cubed plus x squared minus 5x. And we're going to subtract the negative x. Okay. I used brackets. I probably should have used parentheses here. All right, and then for the section of the graph that we'll call B, B is going to go from 0 to 1, and on this particular one, it looks like the negative x is the higher function. So that's going to be the first one, and then we're going to subtract the cubic function. And we'll integrate separately. So with each of these, I'm going to simplify anything that I can first. For A, I've got a negative 5x minus a negative x, so that gives me 3x cubed plus x squared minus 4x with respect to x. And for b, I end up with a minus 3x cubed minus x squared, and then I'm going to have plus 4x. So you notice that they are the opposite of each other with regard to the signs. So now I integrate each piece. I've got 3/4 x to the 4th plus x cubed over 3 minus 2x squared from negative 4/3 to 0. And then I'm going to have negative 3/4 x to the 4th minus x cubed over 3 plus 2x squared, and that one's going to go from 0 to 1. So now I just have to plug all of this in. So we'll have 3/4 times 0 to the 4th plus 0 cubed over 3 minus 2 times 0 squared. I wonder what that's going to be. Minus 3/4 times negative 4/3 to the 4th plus 1/3 times negative 4/3 cubed minus 2 times negative 4/3 squared. Let me just see if I can scoot this over just a hair so we have some room. Yep. Okay, because that's only one of the integrals. Now I'm also going to have negative 3/4 times 1 to the 4th minus 1 cubed over 3 plus 2 times 1 squared. And then just because I'm running out of room here, you notice if you plug in a 0, you get a 0 there. So we'll just leave that as it is. So this is all 0, this is 0. And when I do some arithmetic here, I've got the negative 4 is raised to the 4th power and the 3 is raised to the 4th power. So keep in mind that everything does go positive here, and I end up with if I add all of this together, if I multiply all this together, I get 64 over 27, because one of the 3's and one of the 4's will cancel. Here I'm going to get minus 64 over 81, and I'll have, this was a minus, that got lost in translation. Here I'm going to have minus 32 over 9 when I square all of that. And here I will have minus 3/4 minus 1/3 plus 2. So when I add all of that together, I get 937 divided by 324 units squared. That is a crazy common denominator, but there you go.